Hi everyone, we're going to discuss the clinical UPS here. For the first question, given function has a root in the interval of -1 and 0. So by algebraic method, we are going to substitute -1 into the function and 0 to the function. Since it has a root in the interval, means you are having an opposite side. One is negative, one is positive. So statement 1 and 3, they are correct. So equal sign won't have roots, so this is wrong. So by sketching the graph, if you're using graphical method, roots will be happen for the graph intersect with x-axis. So we are finding what is the value of x. So it's not y-axis. Question number 2. So we are finding the cube roots of 21. So x equals to cube root of 21. Form out our function. So our function have to be polynomial function so that it will convergent function. So move our cube root, it will be x cubed equals to 21. Then move it to the left hand side, minus 21 equals to 0. Therefore, our function suitable to use in Newton-Raphson formula, it will be x cubed minus 21. So differentiate this function, it gives us 3x squared. So to find the Newton-Raphson formula, Sn plus 1 equals to Sn, and then minus function Sn cubed minus 21 over differential function, which is 3Sn power of 2. So look at the answer here, it will be option number 3. Then the equation of 2x minus 3 ln x plus 1 equals to 0. Since this equation already equals to 0, means that it's ready to be our function. To use Newton-Raphson method, we need to differentiate it. So differentiate ln, sin is equal to ln, at denominator, differentiate x, at numerator we get 1. So this is a formula that we need to use it. With initial value x equals to 1, so we put in our formula x minus fraction of fx to alpha x minus 3 ln alpha x plus 1, then 2 minus 3 in the bracket of fraction 1 over alpha x plus 1. So we're going to calculate for the initial value, which is 1. So they ask, what is your next approximation? So what's your x2? So when x1 equals to 1, then x2, we're going to substitute our value of 1 into the formula. So I write it in short because this one just objective. Then we press calculator, calculate for x equals to 1. So it gives us 1.58883. So we round off to be 4 significant, 1.51588 become 9. So answer is this. Next, when we differentiate this, so what is your correct answer? When you differentiate A, you get B, means when you integrate B, you will get back A and plus C. So this is our antiderivative concept. Which one writing incorrect? So option is number 2. Then find this integral. So what can we do when we have denominator only have one term? We can simplify this. So this is integrate x squared divided by 1 over 2 means power of minus 1 over 2 plus 2x 1 minus 1 over 2, then plus 4x power of negative 1 over 2 dx. So we are integrate x power of 2 minus 1 over 2, 3 over 2. So this one is x power of 1 over 2, and this is 4x power of negative 1 over 2. When you want to integrate that, it will be power plus 1. So power plus 1 become 5 over 2 over 5. And then we flip out the division 2 become multiplication. Then again for this one, 2x power plus 1, 3 over 2 over 3 times 2. And then plus 4, the x power plus 1, 1 over 2 divided by 1. Then times 2 plus c. So don't forget your plus c. So we check answer here. 2x 5 power 2x power 5 over 2 over 5. Okay, so this is wrong. Therefore, option 3. This question, as we can see, this question can be simplified. We expand first 3x cubed and then plus 21x dx. So integrate power plus 1 over new power, then power plus 1 over new power, then plus c. So look at the answer. Our suitable answer will be option 4. Then for next question, to integrate a bracket of linear. So this is formula number 3. A bracket of linear, just the bracket plus 1 become negative 3 over new power. Don't forget the coefficient of x, negative 3 plus c. So this will be 4 minus 3x power negative 3 over 9 plus c. So here we have our answer. Then number 8, evaluate this. If integrate q to p fx is negative 5, p to q gx is 5. So first of all, we simplify this integration. Here will be 4 integrate p to q for fx dx minus another function integrate p to q for gx dx. So integrate p to q for gx, this is 5. But for function fx, integrate q to p. So we inverse the limit. It will become negative. Come back to integrate q to p for fx only. Then we substitute. This is negative 5. This is 5. 20 minus 5. So it gives us 15. So here we go, our answer. Then by using substitution, find this. So actually this one, we can try with our formula first because this is second times tangent. fx, I let it to be tangent because differentiate tangent, we can get second square. So again, giant function, integrate fx. And then at the side here, we have f prime x. So straight away, the function power plus 1 over new power. So this one, this is fx. This is f prime x, directly same. So therefore, power plus 1, which is tangent square, over 2 plus c. So not necessarily substitution. Unless you didn't learn this formula, then you use substitution. So here we go. This is our answer. Then next, given that this fraction already expressed in partial fraction, so we need to integrate this. So we substitute our partial fraction. The first one, the fraction 2 over 3. We factorize, simplify the constant. Then plus 1 over 3 integrate x minus 3 dx. Alright, so we substitute this fraction, which is partial fraction. Then we see the constant. We factorize out. So once we factorize out, we can integrate it simple. 2 over 3, this is ln x, plus 1 over 3, this is ln x minus 3. Since our denominator all are in linear, so we just ln on it. Then coefficient x also positive 1. It doesn't make any changes. Plus c. As we can see, our answer here, 1 over 3 already factorized out. So means here is remaining 2 ln x. And then here will remaining ln x minus 3 plus c. So 2. Using the properties of the log, we simplify it to be carried out, become the power. So it will be ln x squared plus ln x minus 3. So when ln plus ln, you were having the multiplication for x squared times with x minus 3. So make it to a single ln. So our answer will be x squared times x minus 3. So here will be our answer. which of the following is correct to solve this integral? So x times exponential, two different functions, multiply it together. So it doesn't have our formula pattern, so we try to solve it by integration by part. So integration by part, identify our functions here. X is polynomial, p is exponential, so our u will be log back, x to be selected. Then dv is the remaining part of the questions. So differentiate u with respect to x, we get 1, so du is dx. Then for dv, integrate both sides, v will be e 3x over 3. So integration by part formula, u times v, then integrate minus integrate v du, which is dx. So which one is our answer? 1 over 3x, e 3x, so they are same, so minus this one. So 1 over 3 factorize out. This is our answer. To integrate 3, go. So 20, we factorize out. We integrate sine with the angle mx. So to integrate sine, we'll get negative cos mx. Don't forget, divide with its angle here. Angle here is mx, means you need to divide with m, then plus c. So simplify, we get negative 20 cos mx over m plus c. So this is our answer. Then integrate tangent square. So to integrate tangent square, we factorize out 3. Tangent square we can simplify using identity, where tangent square plus 1 equals to secant square. So tangent square equals to secant square minus 1. So once we change it to secant square, integrate secant square will give us tangent. So we can use our integration formula directly. And integrate 1, we get x plus c. So to expand back this, it will give you 3 tangent x minus 3x plus c. So this is our answer. Next, what is a possible antiderivative for this? So antiderivative of this means integrate of 19x cubed with respect to x. So power plus 1 over new power plus c. So look at our function here. Yeah, plus c possible. This one, 19x power 4 plus c also possible. 19x over 4 plus c. So all the constant here possible. So 1, 2, 3 will be our final answer. Then next, to integrate this, so fraction, denominator linear, so can do direct integration, which is give us ln 2 minus 3x. Don't forget, divide with your coefficient x, which is your a here, negative 3. Then upper limit is m, lower limit is n. So try to simplify this. As our negative 1 over 3 we take out, and we substitute upper limit 2 minus 3m minus ln 2 minus 3n. So ln minus ln, it gives us simplify to a single log, where the item here will be in division. So we look at the answer. Seems like we don't have if you have negative. So why not we simplify? We move back the negative back to the ln here. It will be 2 minus 3m over 2 minus 3n power negative. So power negative means we need to inverse the fraction. So numerator go down to denominator, denominator go up to be numerator. So 2 minus 3n and 2 minus 3m. So the nearest answer will be in this form. Next, which of the following describe the region bounded by x-axis and then the curve and then another curve? So your region have 3 boundary here. X-axis, the quadratic curve, and another quadratic curve. So bounded by these 3 boundaries, it will be the region of Q plus R. Then for 17, the graph shows that the region bounded by 4y equals to x squared and y squared equals to 4x. Determine the correct formula to find out the region bounded. So you want dx or dy. Since you see your option here is dx, means we're going to see it vertically, refer to x-axis. So when you refer to x-axis, you can notice that we have two curve concept and our region doesn't attach to x-axis. Therefore, to find area, it will be lower limit, which is 0, up to upper limit 4. So two curve concept will be the curve up here minus the curve down here. So y1 minus y2 and dx. So our curve must be y in terms of x. So let us simplify the y in terms of x. Here will be y equals to x squared over 4. So for this one, y will be square root 4x. So therefore, area formula, integrate 0 until 4. Up here is square root 4x minus the curve below here, x squared over 4 dx. As square root 4x, it will be equal to square root 4. We take out 0 until 4, x power 1 over 2. So minus the constant here, factorize, remaining x squared dx. So also from 0 until 4, then our closer answer, square root 4 simplify become 2. So here will be the answer. Next, how to decrease the accuracy of approximation defined integral by using trapezoidal rule. So trapezoidal rule means you are finding area using trapezium. So your accuracy will be decreasing when you're using more bigger trapezium. As you see, when you're using more bigger trapezium, your area covered by the trapezium will not as close as the smaller trapezium. So if you have smaller trapezium, so we can close up the area more accurate. So this is more trapezium that we use. So we will have less error there. So to decrease the accuracy, of course, your subinterval must be smaller, lesser. So increase will not increase, will increase the accuracy. Then decrease the value of y. So the y here, we get decrease, we get it small. So we get it small, it will increase the accuracy. Decrease the number of trapezium. Yes, we use less trapezium. Then increase the value of y. So increase the value of y of the trapezium means we use bigger trapezium here to cover up. So this one will make your trapezoidal rule less accuracy. So answer 3 and 4. So the table show the function and the value that already calculate here. So this is your first, this is your middle, this is the last. By using the formula for trapezoidal rule, so we need to approximate this one. So what's your h? So your h here, your interval here will be 0.5 over 2. Then the first y and the last y together 2.0318 plus 2 times in the middle y here. Middle y here will be 1. So our answer will be equal to 1.00795. So they want us to correct to 3 decimal. So 79 will be round off 1.008. So our answer is this. So that's all for this discussion.